Hello, both of y'all. Especially on an early Saturday stream, I don't expect large crowds in either of the laser or the CNC. But especially the CNC, as I'm still developing my skills and my abilities, and growing the channel. I'm not expecting to see a huge rush of people to come hang out and chips and chat. And I've been running around like a chicken with my head cut off all morning long. I'm trying to prepare for both streams, this and then the 9 o'clock laser stream. But mostly my time this week, did the project with the patrons and got it up online, and I've been spending a tremendous amount of time developing this Inlay calculator. Now, for the seasoned professionals out there, or the really experienced CNCers who have been using Vectric and VCarve and Aspire, all these Fusion 3, all these others, and they've got it completely they understand it. They know it inside. This may be a useless tool, but for folks like myself, I've looked at those advanced CNC softwares, and I just couldn't grasp it. I don't understand what MillMage is doing. The terminology, their explanations, none of it makes any sense to me. And so I said, all right, there's got to be a better way. And when I say that, a better way, there's got to be a better way for novice folks who have no experience with this to begin to see and comprehend and understand what's going on than what they're using. The terminology and the equations and their techniques. Oh, wow. I never clean the glasses until I'm going on stream, and I'm like, anyway. So welcome to everybody. Disclaimer: I don't know what I'm doing. Okay, I'm learning CNCs. I'm learning MillMage. I am going to embrace MillMage wholeheartedly, or I have embraced MillMage wholeheartedly. I do not intend to, go into any of those other softwares. But, and I've made the comment before, I'm trying to run before I can crawl with my techniques, my abilities, and what I want to do with the CNC. And I'm asking a tremendous amount from this little thing. For anybody who has bought a Cubico, you've probably experienced, like most folks have, problems. I was having issues, and I was finding workarounds for it with its homing and losing position. In fact, the one I gave away to Scott won the Cubico on this channel. He was having some problems. He couldn't even get the firmware to fix it. Cubico ended up sending him a new machine. Ed, I know he's bought one, and he's did the firmware update. He's having some issues, and they're trying to get it worked out. But it's not an expensive machine. And once you get all the bugs worked out of it and you get it working, I've got mine working flawlessly. It's doing what it's supposed to when it's supposed to. So now it is a really good machine to learn to do what I'm trying to do. I'm learning the techniques, the operations, the bits, what you need to do to accomplish certain things. To do a simple engraving, a simple carving with of either V-bit or even a bull nose or a bowl carving, if you're putting a pocket in something, it's not that big of a deal. It's easy. That's pretty simple. Where you start getting into the complicated things are trying to do the inlays. And that's where you can make some good money if you're going to, probably not doing, big projects and inlays with this, but learning with this and then moving up to the big machine I got in the other room, or maybe even a bigger machine in the future. But cutting my teeth on this, making it a whole lot easier. And I can tell you right now, Chris, you can, whenever you're talking to the guys and gals in the support there, and for you yourself, I know you help with the coding and light burn. Anybody here in this stream that has been using Lightburn for a while and you've upgraded to that 2.0 and you've been having nothing but problems and crashes and problems, and it's been a nightmare since you went away from 1.7. Y'all have no idea, most likely, what's involved when it comes to the coding and the back end, and how something so simple can crash the entire thing. And you're like, what in the world? And you've tried to implement one simple little change, and it ends up affecting 10 other things that weren't broken before. And you do one thing and it breaks 12 others. Well, in developing this Inlay calculator, I started out with something was really a basic. It was going to be just a calculator for calculating the male inlay. I've got my knowns, I've got my pocket size for the female pocket. Now I'll use this calculator to tell me what's the best offset to get the male inlay, because when you're doing V carving, you don't just carve a 3 millimeter ditch and then create a 3 millimeter bump and put it in there. It don't work that way. When you're working with V carving, if anybody's had any experience trying to aim your satellite dish at that satellite in space, you move it just a little bit here and you're 100,000 miles off out there. So it's kind of the same thing with your V carving. Move a little bit adjustment one way or the other, and it can make a huge difference in whether it fits or don't fit. And all even the softwares that are out there that have similar verbiage and terminology, a lot of it don't make any sense to me, because I've not used it, and I'm like, okay, well, the name it doesn't fit what it's what it is. I'm like, okay, I need high school education verbiage in plain English, simple terms. I'm not a simple person. I'm a very logical person, and I'm not a dumb bunny. Obviously, I'm going to get ready to show you what I've got worked out here. This is some complicated stuff, but I've made it so that it is idiot friendly because I did it. So I sent and I see a lot of familiar faces in the stream. Chris is here. I'm glad you're here. And Jack in the shop may be listening. He might make it in here later. He had to go run to cross county line, but I sent Chris and Jack in the shop both a link to the stream. So Chris, if it gets to a point where you're like, wait a minute, I want to chime in and talk about this or do that, you've got a link that you can come in anytime. But I have a new respect for the coders in Lightburn, and I fully appreciate and respect how those things can happen where you do one thing and it breaks 12 others. Real quick, I told you I was doing a calculator that was only going to work to calculate the male inlay. That's all it was going to do. And then Chris made the comment. He says, it wouldn't be that much more to where you could, do the inverse and have it create the female pocket. You know, if you had a male, you can have it create the female. I said, okay. So now it's not just a male. It's now a full-on V-bit inlay calculator, female or male. And then I'm like, okay, well, straight end mills are simple. A straight end mill, it is just like with your laser. You're cutting a 1/8 inch groove if it's just a profile cut, and then you just need to leave a 1/8 inch male proud that you can put down in there, and it's, you know, no big deal. So I do have an end mill, a straight end mill calculator on here, but it's nobody even needs that really. But it's in here. And then it's funny enough, Chris mentioned doing the tapered ball nose end mill. I don't have one of those yet. I got to get one. And I said, okay. And a tapered ball nose it varies. It differs than a V nose or a V bit. V bit comes to a sharp point. All right, it's a V. A ball nose end mill has a taper on it, but then they put a ball, so hence it's a ball nose end mill. Well, those ball noses have different radiuses, different sizes. You've got different angles on the V of the ball nose, on the taper of the ball nose. So a tape, what's his name? Ryan from CNC or Cutting It Close. Ryan did a video just a couple days ago, maybe last week, where he did, I think it was his first ever video on tapered ball nose inlays. And he opened the video with, this is this most difficult type of inlay you can do. And he had to go take a special course with a friend or whatever to get trained and learn how to do it. And then he said, I spent hours and hours and hours testing to find the right fit and the right offsets. So that's where I think this calculator is going to come in really, really handy. It's super handy with the V nose or the V carve. But the bull nose I think is going to save a tremendous amount of time. And where this really can come in handy is the reason I did not do Vectric or V-Carve or Aspire or Fusion 360 or any of those others out there that are the really, really advanced CNC softwares. Expense. Couldn't justify it. Couldn't, just starting out, not knowing what I'm doing and trying to figure out. A lot of them had a 30-day trial, or I was able to convince them to let me do that. I couldn't even begin to grasp it. So I'm like, I'm not spending this much money. Nuh-uh. And then the basic ones out there, like Easel and a few others out there, it's basically a straight end mill carve where you can do, okay, I can do a pocket, or I can do it's basic. But I believe with a very basic software program like Easel that has the ability to do full-on control for your CNC X, Y, and Z, you can use that along with this calculator, and you can do V carving and all kinds of special stuff that, and I don't know if Easel's ever come up to that or not. Easel may have V carve, but at the time it didn't. So let me just see if there's any comments or questions, or just before I show you this here. And again, thank you all for popping in and saying hey and hanging out for a few. A lot of familiar names, a lot of familiar faces. Appreciate you all. Let's see, just want to make sure. Well, that's a new name, I think. I think Melissa's added on to her. Melissa's Creative Hideaway. Missed you too. Glad to see you back. Yeah, and as Bob says, and I bet the 37 of you that are here have subscribed, and I greatly appreciate it. But if you're not subscribed, hit that subscribe button. Help me get this channel up and going. The more people that subscribe, the helps the algorithms to get that pushed out, and they'll promote it more and more. But all that said, and Chris threw me a curveball last week. I thought I had a pretty good working version of the calculator. And so I said, okay, give me three numbers, give me three values or whatever. And I didn't catch it. But Chris gave me a depth, a pocket depth that was less than 2/10 of a millimeter. And I was trying to do a glue pocket of 2/10 of a millimeter on a pocket that was less than two. So Chris threw me he didn't even throw me a curveball. Chris threw me a screwball. Uh, so, but I've made some changes and made some improvements, and Chris says YouTube seems to have made some changes. All the names are showing up differently for me. Huh. All right. So before I show you the calculator, I'm going to pop over here to YouTube, not YouTube, got me thinking, over to Lightburn and swap over here. And real quick, if you had a block of wood and you were doing a straight end mill carving, and it was going to be 5 millimeters deep and ended up being, I don't know, 50 millimeters wide. Say, and that we're looking at the side profile, so that actually could be that could be a 50 millimeter circle if you're looking at it from the top down. The side profile is still going to look like this. And if that, Control D, if that was what you were engraving in here, so you said A subtract B, if that was the pocket that you carved in with a straight end mill, then this is exactly what you need for your male inlay with a straight carve. It fits in there and glue it up, and there you go. And that is kind of what we've been doing using the lasers when any of us have been doing inlays with the lasers. We might, allow for the kerf of the laser. Here you might go a little bit, out to make it a good tight snug fit. But regardless, your male inlay is a mirror of the female pocket when you're doing straight end mills. Those aren't the challenge. And it's kind of funny because I've been talking about these inlays for the last 2 or 3 weeks, and Ryan, cutting it close, his like I said, his video he did, I think last week, was like, inlays, easy, a little more challenging, extremely challenging, and it was straight end mills, V carving, and then tapered. And I'm just, on the same subject matter, and coincidence, but I guess it's, when it comes to CNC and you're talking about inlays, there's only about 2 or 3 topics that you're going to talk about. But let me show you the difference with what you get with the V carve and why it's the male pocket, the male inlay is super, super tricky. And this is partly why I don't understand how or what Mill Mage is trying to do when it does what it does. But let me show you what you got to do. If we take this same piece of wood and we're gonna get rid of this, and I'm gonna fill that hole back in. Get rid of those. There we go. All right. If I'm using a 30-degree V-bit, 30-degree V-bit, not cap locks, hold my shift button, draw a straight line, grab that, and I'm rotate it negative 15 degrees. Now I'm going to duplicate that, and I'm going to mirror it so I can create the V bit for you guys, just so you can see what's happening. Alt Shift 8. Come on. That and Alt Shift H, and we'll join those together. Alt J. All right. So that's a 30-degree V bit. It comes down to a point, and each side is 15 degrees. The included angle or the combined angle is 30 degrees total. And if that's going to come down here and carve in a pocket, well, the deeper you go, that angle's changing. So here's the kicker. If I've got this right here, this is a 50 millimeter disc, a circle. So if I look at the profile of it, are you using Lightburn and not Milmage? I am using Lightburn here to demonstrate what's going on, because that's the beauty of, and why I've been waiting on Milmage, and it's the same. The only difference, Milmage is now incorporating the operations and being able to control that third axis. But, and you'll see in a second, and Chris mentioned this in one of the other streams. He said, if you had that in different colors, people might see it better. But also not just different colors, because sometimes the colors don't show up so well on your screen, depending on how big it is and how good you're at. But I'm going to be putting some stuff in fill mode. So and you can't do that in Milmage. So this is just for demonstration purposes. I'm talking about theory here. I'm not talking about practice with anything in any of the softwares. Just explaining to those like myself that are just beginning to wrap their mind around what's happening when it happens. So yes, I am using Lightburn here. You need a 3, 60, and 90 V-bits in your art library. Oh, yeah. So I can just pull it in. Yep. And I ended up doing some similar stuff. I didn't save them in the art library, though. That was bad of me, because I ended up having to create a bunch of different tools, and which we'll use this over and over again today. But there's my, delete that. There's my V-bit, and here's a 50 millimeter disc looking at it from the top. But if I look at it from the profile, it's going to be 50 millimeters. But then if I'm wanting to do it as an inlay, how deep do I want to put this into my material? Let's put it in here at a 5 millimeter thick piece of material that's going to inlay in here. But the size, and right here, I'm telling you it's a 50 millimeter disc. But that may not be what the male ends up being, depending on which way you approach it. And that's why I ended up liking the calculator the way I've got it, where you can calculate the male or the female, because if there was something about it that was specific, that this had to be at the top surface, say you were doing a game board or something, and you needed that top surface to be exactly what it was going to be. If you were going to do a checkerboard and you wanted to have every single square to be exactly 50 mil at the top of each square, well, then you needed to calculate you'd calculate it differently. I would calculate the male and then figure out what the female pocket needed to be, because they're not the same. Check out what happens here. If this is a 50 millimeter disc, and that's what I programmed here to go in here and do my pocket, a 50 millimeter disc. Well, because this is my bit, and depending on the software, and this is where I get lost with, like, Milmage is, I think Chris explained to me, Milmage is coming inside the line to cut the pocket. And there may be some other stuff going on in Milmage, and because I still don't comprehend fully where they're taking the measurement from, because if this is a 50 millimeter disc and it's cutting inside the line, then where does it determine the cut line is? If I've got a straight line here, and if this was sitting right there at the perimeter, or at the bottom rather, well, that's not doing anything. But if it comes up here, it's 5 millimeters. Well, is this the cut line then? Because this is where it comes into contact with the material. And if it's going to cut inside that line, and then the pocket's going to, that's the pocket, and then the male's going to cut outside the line, then he's a lot going on when it comes to inlays, a whole lot. And that's why I like my approach to it, opposed to what the other guys have done or are doing. So let me just show you what mine does and how I figured out my calculator. And then some of you more experienced folks might go, well, it's the same thing. You're doing, one is white and the other one is alabaster. They're the same thing. They're just calling it totally different, but it's the same thing. So here's what happens. If right now in my mind, if I send this out to cut a 50 millimeter disc, I'm coming down here, and if I cut the line, there's the line on that 50 millimeter disc. It's cutting there, but I'm 5 millimeters deep. So now the top of the surface of this is out here. And then once it gets around to the other side, it's going to be the same thing. It's not going to be 50 millimeters anymore. So if I take this and duplicate it, I'm going to keep one over here. And I'm going to grab this one and bring it over here so you can see what's going on with the full visual representation. Chris says calculations are done from surface point of view, as that is the visual result you're after. Okay. All right. So the way I've got mine figured out, the way I'm starting to understand this, if I'm cutting the line on a 50 millimeter circle, we're looking at the profile. This is still a circle, but we're looking at the profile. And I cut the line, well, that bit is going to be, half of that is going to be over here. And so I've got to extend this material out to here. And then if I cut this all out to give you the actual representation, I cut that one. Oh, Control Z, cut that away, cut that away. Will that cut now? There we go. So now, what was just a 50 millimeter pocket is now 52.69 millimeters if I cut the line. And that's where, and hey, Jack's joining in. Hey, buddy, how you doing?
What's going
on? Let's see here. John says, I think it calculates where the side of the bit hit the inside or outside of the line at half the width of the base. Yeah. Now, see, boys and girls, y'all, did y'all follow everything John just said? I think it calculates where the side of the bit hit the inside of the outside of the line at half the width of the bit based on your depth of cut. Now,
no.
Well, Jack in the shop says no. And anybody who hasn't met Jack, this is Jack.
How's it going?
And Jack posts some really impressive stuff from his CNC and his lasers. He's an experienced and nope. Or hey, Melissa says hey, and she says nope. LOL. So what I've done, John, I'm not laughing at you because I couldn't understand half of this stuff anyway. but my approach on it takes all of that stuff and makes all of it irrelevant, because I've made the calculations, made the calculator take any of it and all that stuff into consideration. And for an elementary person that don't know what they're doing, it works really, really great. So, Jack, I'm going to go back to full screen so you can see what this does when it does what it does. And like I say, it may be a different approach than what everybody else is doing, or it might be not just different, but a really novel or slick approach. I don't know. So go back here, go back to full screen. So, and if I look here at the measurements of this pocket, because that's what this is going to be, that bottom line, let me pull my measurement over here. There we go. That bottom line is still my 50 millimeters, because that's where the V-bit cut was, riding the line and cut that out. But because it's a V-bit, it's now bigger at the top. It's 52.68. So, and right now I'm showing you what happens when you do what you do. And then I'm going to show you how the calculator makes this so quick and so simple. So I'm going to duplicate that and put it down here, center and the top, create the pocket, cut. There we go. All right. So now, if you took this and you've got to create and this is where it gets it was even troubling to do the calculations, because when you're doing when you're carving the male, you're carving the inverse image and you're having to flip it over, and you're carving it from the bottom of the inlay to the top of the inlay. You're carving it upside down both ways. It's the image is inverted, and you're actually, you'll see. So if I flip that over, this right here is not, if I was carving out the top of it, that V-bit, now let me just get rid of that. We'll get rid of that completely, because if this is how I approach my inlays. I said, all right, I got a 50 millimeter and I've carved that out and I've carved the line. Now, how do I figure out what that male is? The male has got to be wider. We just seen it was 52.69, but how do I know what that is? If I didn't, I could take my ruler and come over here and measure from that gap to there and say, okay, well, that's actually bigger, because I didn't get right on it. But with this calculator, see, Alt Tab, I come in here, I'm wanting to do my male inlay, and I'm going to use my basic calculator. The difference between basic and advanced is the advanced will allow you to put in a glue pocket, an additional standoff, and all kinds of stuff. But we're not going to even talk about that right now. Basic. I've cut with, and I see I'm using a V-bit. I cut with a 30 degree angle V-bit. My pocket depth is 5 millimeters. I don't want any standoff, and calculate. It tells me I need a 1.34 millimeter offset, and my male insert is going to be 5 millimeters. So if I go back over here and it was 1.34, yep. So I take my original pocket, my original design, and I tell it I need a 1.34 offset outward, and say, okay, well, there is the dimensions. It's 52.688 in width. Should have been the same, because that's a circle, but so 52.68. So if I draw out a rectangle, and it needs to be 52.68, and then I need to make it 5 millimeters in height, and then I need to put my carve it with the V-bit. So if I duplicate that and bring that down here and carve that out, but now here's where it gets tricky. Remember, we're doing it upside down. So duplicate that, and let's bring this over here. So if that's going to carve out like that, and I do, and And I've been doing this for 2.5 weeks, 3 weeks, and I still have to stop, take a break, walk away. Even though I have started to grasp it and I've got this working, sometimes I get lost in the weeds just trying to wrap my head around all this. So there is my offset, 52.68. I'm going to carve that out. I need to get my scissors and get rid of this and this and this, because this is carving down from the surface. Some folks were giving me a hard time last week and said, "Oops, go back." Control Z. I didn't draw that over there, did I? Yeah, I just didn't draw that one out. They said, you know you can flip. I said, yeah, but I'm trying to show you how the CNC is going to approach this. The CNC is carving down. So now scissors. So get rid of all the extra to create that male. All right. So that's going to come off the CNC. And when you do, you're going to take that, flip it over. And if we center that up until it go to, there you go. That's a perfect fit. Absolutely tight all the way around. It's exactly what you need it to be. And all I had to do was put in, let's see. Oh, let's see. Jack's got some stuff he's added here too. But all I had to do was put in my original dimensions of what I carved, and it will calculate the exact offset that you need to fit that pocket perfectly.
But that's not how the CNC is going to approach it, though.
It doesn't matter how the CNC, because that's what I'm taking the inlays and the pocket. I'm just using just a regular pocket. And if I tell it this, if I'm not telling it it's an inlay, I'm just telling it, go cut this and
Right.
then it's going to work.
But it doesn't matter whether you're using an inlay operation or a pocket operation.
Okay.
The CNC is taking into the fact that you've got the 90-degree V bit. It's making those calculations. So it knows exactly you want this to be. I'm just saying, for instance, I got mine set to a flat depth of 0.11 inches. It will carve inside to the top surface will always be perfect. And when you do you got your box round for your male piece,
Yeah.
it's going to carve around to the outside of that line, and it's going to keep the edge of your V bit on the outside of this line. So your top is going to be perfect always. When you're on the female part, the edge of that bit is going to ride on the inside of this pocket. So that's why you don't really have to calculate. It's not going to make any one bigger than the other. They're both going to be perfect.
But what was that, V-carve?
Huh?
Is that V-carve?
It doesn't matter. It don't matter if you're doing a V-carve or a pocket. What matters is the computer sees your angle of that bit, and no matter which one you pick, it knows what bit you're using, so it's going to keep inside of the vector. Or if you got your box drawn around it, it's going to carve on the outside of that vector.
Yeah, Millmates
don't fit perfectly.
Yeah, Millmates don't work like that.
I tried Millmage. I couldn't get Millmage to work.
Yeah, and so that's why I'm approaching this from the point of view of trying to use Millmage, and I cannot understand, because none of that terminology you're talking about there is in Millmage. You set up your tools and set up all that, but as far as the flat depth and all that, they call it something different. And I hear what you're saying as far as, yeah, it's supposed to, one's going to cut the inside, one's cutting outside. And I've still got, like I said, I don't know what I'm doing.
Right.
I'm still trying.
Even in Millmage, if you just use a pocket, I think they do have a inlay up function, but even if you're using just a pocket, it should work the same way. And if it's not, that's a problem within Millmage, and they're going to fix that, and that's not going to be usable for inlays.
They have a female pocket inlay.
Yeah, I saw that.
And a male inlay,
Right.
And Chris showed me that it does in there. The illustration is, and Chris, forgive me, and I've apologized to you before, if it was your personal drawing and illustration, don't take it, but it looks like a kindergartner did it. It makes, it, and I've not been happy with any of the illustrations that Millmade or that Inlay or Millmage or Lightburn has ever used. Half the time, my brain can't comprehend what they're trying to illustrate with a drawing. It just never makes any sense to me. And Chris helped me begin to understand what those illustrations were trying to show you. But with the way that my calculator approaches it, I'm calculating it from because I'm telling it the pocket depth. I think that's your flat depth.
Right.
All right. And then if I want to do not my drawings, that's just how they interpreted it. Okay. Yeah, not my fault. But my calculator, I'm assuming that the thickness of the inlay is in fact, I'm gonna pull that off. If I tell it the pocket is 5 millimeter pocket, that's flat depth. But then I've got the ability to put in a glue pocket, and the calculator will subtract a 0.2 of a millimeter or whatever you want it to be for a glue pocket, and it still calculates the correct offsets and everything else and it's kind of funky when the glue depth or the glue pocket won't affect your male height, but it will affect your female pocket. And that's where I was trying to use one description for glue pocket in the calculator, but it turns out I had to have multiple descriptions because depending on if it was male or female, because that's where I said you can make one little change and it crashed the whole thing. I had to rewrite my code probably 3 times before I finally got everything done, and I've got everything isolated to where it's own separate. They're not using the same terminology. The glue depth or the glue pocket. It's got one term for the male and it's got a whole nother term for the female. That way they're not using the same one. Because one will crash the other.
I honestly don't understand a glue pocket anyway. You don't have a glue pocket when you glue 2 pieces of flat wood together, but oh well. I do use a glue pocket at the bottom of my V carves.
You do, or you don't?
Or my inlays. I'm sorry. Yes,
you do.
I do have a little bit of gap on the bottom, but none on the sides.
None on the sides. And I took that and to put my side gap at 0 as the default. But in the advanced calculator, the advanced model, you can change glue depth or the glue pocket height. You can change side gap. You can change all the parameters. And why I say I like this better is I hear what you're saying that, okay, well, if you're using this and you're doing a V carve and you've told it it's a 90-degree bit and then it knows what to do. It just does it. Yeah. Well, unless I comprehend what it's doing, I can't wrap my mind around it. I need to see how the sausage is made. And so,
of course, it'll take some practice and just like anything else. But if it's doing anything other than keeping this vector, well, you can't see my screen, but if it's doing anything other than keeping the surface vector accurate, it's not doing proper. It's not working properly. It should always stick with the surface vector, and your bottom vector would only be calculated by the angle of your V bit.
Yeah, and with the wet and I will. And here's the thing. I seriously do believe, and I'm going to get you a working copy of this and let you kind of kick the tires on it. I showed it to Chris, and Chris, when the very first couple of versions, and he's like, yeah, this is pretty interesting. I think it's going to work flawlessly, and it's so simple that the very beginner user CNC is wanting to, okay, well, I know, yes, yeah, you tell it, all those things that you say that Vetric and V-Carve and all those guys it just does it. Here, you tell it what to do. All right, it's like I don't have to count on it doing what it's because you do have to do certain things. It's like one time I was watching Garrett, and he did the feather inlay, and he's like, okay, in order to get the best possible fit, you need to use these values and just put these in and use these values in this field, and it's going to work flawlessly every time. That's not an answer that works for me. I need
The only
to know.
thing he was talking about there was the flat depth
Yeah,
too, because like I said, I need to dive into Millmage a little bit more. I need to try to actually do one in Millmage. I didn't look at it very long before I realized, and it might be the version that I have because I'm still using one of the older RC versions of Millmage.
yeah. Well, I've got the most, but I've got the most up to date. But and Chris and he explained to us last week that the verbiage, the terminology is because it was written by someone who's not English was not their first
Oh
language.
yeah, I saw that
But
comment.
it may get better, but even still, it just there's not enough information. Uh, this is coming from a novice, from a dummy who don't know what they're doing. I need to know what the machine's doing because I don't know what I don't know what it's doing. I don't know what it's, I don't know that these things are automatically happening, or I don't comprehend, all the automatic stuff that, they're taking for granted. Well, I want to see, I want to do it.
I hope ain't nobody looking at me like some kind of master either, because I'm just a guy in the shop with a couple of toys.
But your couple of toys, you put out some impressive stuff.
Oh,
Jared says if you did a 1-inch square pocket and measure to see what it comes out, may tell you if it's cutting inside or outside. Yeah, well, it's not. Millmage's female pocket cuts inside, and Millmage's male cuts outside. Seeing the numbers on screen and seeing them change as you modify the numbers helps you understand. Yes, exactly. I want to see it. And if I go back over here and this is what's really cool. This is what's really cool. We just did let me switch this back and go back to full screen here. Solo. So that we just did a simple male inlay to fill that pocket. But some of the guys, if you're doing like the big cutting boards and you got bandsaws and all that, well, we'll go over to the advanced. They'll add a surface standoff so you can run it through the bandsaw and cut your waste off. Then all you got to do is just do a quick surfacing and you're good. Well, here I can come in here and say I'm doing a 30-bit angle, and here I can even change it. Now, tell me this, Jack, or anybody else that's out there that's got experience with this. This V-bit tip diameter. I have searched and looked at different V-bits that are out there, and you can find different values on there, but they're so minuscule. Is that even needed? I mean, V-bits all come to pretty much to a point, or are there any V-bits out there that have a 1 or 2 millimeter flat end on them?
If it's got a 1 or 2 millimeter flat end, I wouldn't even consider that a V-bit. I don't know. They don't have a radius. Maybe it's flat. I don't know that I've ever seen one like that, to be honest with you. A V-bit with a flat tip. As far as I know, they all come to a point. Now, a tapered ball nose, what you were talking about earlier, it comes out to a very, very, very small radius on that tip as well.
And then here, if I go to my tapered ball nose, I've got the tip radius where you can change the radius, and that one is an absolute. You got to have that.
That one is the most important, yes.
But on the V-bit, I don't know that this is important at all. I might can even just get rid of that, because even the ones that measure, some of them say they're a 0.005 or a 0.015 millimeter, and I think if you look at IDC Woodcraft and his information on the V-bits, the specs, I think where he puts the step over for the V-bit, that's actually a tip radius, which would make sense, because if you step over more than the tip radius, you're going to leave a groove. So his step over for the V-bit is the size of his tip radius, I think. But if we go back, go back over here, and we're going to put in a 0 and a glue pocket. What the heck? I'm going to go ahead and put this will be a big one. I'm going to put a 0.5 millimeter glue pocket in there. And my female, like I knew my pocket. The one I just did, it's 5 millimeters deep. Okay. Now I want to leave a standoff on it that's going to be large enough that I can run it through my bandsaw. So I'm going to put a 6 millimeter gap at the top of it. That's the distance between the two top surfaces of the material. And I don't need any extra side clearance since they calculate. Boom. Now I need a 3.08 millimeter offset. So if I go back over to my light burn, 3.08, then I come back to the original 50 millimeters and do an outward offset of 3.08. Then there is my dimensions. I'm going to get rid of this one, delete that. And then this is what the male inlay dimensions need to be, which is 56 point. I don't know why this is, because this I drew out. In fact, you see, that's a perfect. Why is this doing this to me, Chris or Jack? It's a perfect 50-50 XY, but when you do the offset, it comes up with crazy numbers. You know, they're not. It's not a perfect sphere anymore. So I'll do 57.163. So I know the width is going to be that. So I'm going to tell the width to be 57.163. It's about what that sphere is up there. And then if I go back to my calculator, the height on it told me to be 11 millimeters. So a 3.08 outward offset and a height of 11 millimeters. So if I tell this to be 11 mil, and now I use my V-carve bit to carve that out. In fact, what I can do with this, I'm going to close this up and make it an actual enclosure and then just cut with it. See, straight line. There we go. Duplicate that. And that's going to come around and carve that out with that on the line.
On the top line, so you need to move that in.
Because I'm calculating it like it's going to sit on the surface of CNC. I've inverted everything. This material's on there flat on my CNC. The bit comes down and carves that line. So this should work out to where I now, and I can flip that over and rotate it, but that tip would be on the line there. And if I cut this out, then I should have, and I could have used a cut tool. That's why I enclosed that, but I got sidetracked. Squirrel, come on, cut, baby. All right, so that would be how it comes off the CNC. Now, if I rotate it to put it back into that female pocket, and I need to get rid of that one that was in there.
But that's not how it's going to carve.
It is with the way it dimensions I just tell it to.
No, because you just carved inside of your, you carved outside of your vector.
No.
You trimmed it off with your scissors.
I did that because that's the shape of the V-bit.
Right, but the G code's going to tell that bit to stay inside of that vector. It's not going to exceed the bounds of that vector on your surface. That's what I'm trying to tell you. That's not how the CNC is going to read that G code.
It's not going to cut that line.
No, it's going to stay within the bounds of the surface of that vector.
If I send that out to my laser engraver, it's going to cut that out on that line.
You can think of it exactly like the laser. It's going to stay perfectly on the surface of that vector.
That's what I wanted to do.
Right. See, their tip is not going to go to the bottom corner and make your edge make that vector bigger. It's not going to work that way.
No, that's the geometry of the bit it's going to.
No. Since you've told the program what bit you're using, the edge of that bit's going to carve against your vector and not the tip
All right. Let me show you how this fits, and then I hear what you're saying. But if this works because I've used this in the real world, I've not just tested it, I've used it and it works. But I've told this to be a 0.5 millimeter glue gap and to be proud. So if I put that in here, and actually what I need to do is bring a line. I'm gonna bring a line down here and then move that up 0.5 millimeter. 1, 2, 3, 4, 5. That's a 0.5 millimeter. And if I tell this to go to the center of that, and then tell that to go to the bottom of that line, I messed up. I messed up in my geometry, my drawing somewhere, because I've used this 100 times and it works perfect. But it would come out to be that that 0.5 mil up, and then I'll have that excess up there that I can cut off and not have, and I have the perfect fit. But I'm sidetracked now with what you were saying, because I did here. I tried doing with Mill Mage's pockets. Let's go here, and so this bottom one down here, the down 2, I used the settings in Mill Mage, and if you look, you can see the gap that's in there between around the W and the top of the N
and the O and the D.
Yeah, and I just don't like how the D's actually got defects in the wood, but I just didn't like how I wanted a tighter fit. Look how tight now I am is. And that was done using my calculator. I took all of their stuff out of the equation, and it worked. Wrong button. And that's why I would want to, let's see here. Yes, but where is the defined edge if the V carve, the bottom of the point or the middle or the top of the right? For me, with the way I'm doing it, everything is calculated on the bottom of the point. And that's where I think why
it might be working and it actually sitting lower than you think it is in that pocket. So you're not actually getting as much glue gap as you think. That you got two angles, it's just going deeper than you think. Possibly. Because there's no way it should be calculated from the bottom of that carve. Everything should be calculated from the top, from the vector surface.
And I hear what you're saying, that it should be, because that's how you've learned, that's what you know, and that's what. But see,
that's on any program, whether using FreeCAD, Milmage, Lightburn, anything. Because you're told that if you've got your bit programmed properly, that's the key point there. If you got the proper angle, proper dimensions, if you got it programmed right.
Yeah, I got all that set up right. I got all that set up in the tool library.
So you might not be getting as much glue depth as you think. That's a possibility.
Well, taking the glue depth out of it. What are you doing when you get up, when you get done? Have you had dinner today yet?
No, actually, Nina's asking me what we're gonna do, and I told her I don't know. Whatever she wants to do. You want to run down to
Taxco?
Yeah, Taxco.
Yeah. I gotta take Dad to dinner, and we can maybe do that, and I can bring the laptop and show you that, and then get you a copy. But here's the thing. I've used it and I've had positive results in real world experiences, and everything I've done so many tests that it's I just think that I've approached it from such a backward way of doing things, because I don't know what I'm doing, that it works, and it works in a way that no one's thought about approaching it before. Because like you say, it shouldn't work, but it does work. And I've done it with no, glue gap and no, and it fits in nice and flat and gives me no gap. And let's see here.
What's for dinner? That's a Mexican restaurant.
Yeah, Mexican. And I promise if you're here right now and you're going to be back at 9 for the laser show, tonight is I'm growing Christmas trees tonight. I'm going to have Mexican and I'm going to have margarita, but I will be sober for the 9 o'clock stream. That's why I think just start a 1-inch pocket and just work on it and see what it's actually carving.
Yeah, when you do a 1-inch pocket and then you go deeper, 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 you should still have 1 inch at the top with the V-bit.
Well, that'll be interesting to see.
That is a good test right there.
Let's see what's you're doing great. I'm following you. There are always different ways. Yeah, always different ways. Yeah, that'd be a good, easy, simple test. So who said that? Jer? Thanks, Jer. Yeah, I'll do that. But regardless, if I'm expecting, if I'm not getting the values that I'm requesting, if my values are inverted or something's going something different, but because I'm doing it with both the male and the female, they fit and they work. Maybe I'm not in, if I'm expecting a 1 inch at the top, but I go 5 millimeters deep and it's actually an inch down here at the bottom instead of the top. Well, so what? They're both inverted and they're both going to be, it's still going to look right and fit great and do what you want it to do.
Yeah, that's right. If you're doing the same thing with both male and female, you're getting the same values if you hadn't used it. That's right.
Yeah. So, and that's why I think it works. I'm just coming at it from not only a different point of view, but like I said, I honest to goodness, and I think it was a couple of the folks have made in here the comments that they like the ability to say, okay, and again, I've got mad respect for Garrett, and as you said, what he was talking about was the flat depth values or something. But he was there were 2 values. He said just use this value and this value.
Start value and the bottom value. Top and bottom. I don't even know why he messes with the top value, but
I'm like, and I'm like, okay, well, but why? And it's just don't worry about it. It just works. No, I do worry about it. I want to know why.
Yeah, he should have said that difference in value is what gives you your glue gap at the bottom. Like I said again, you don't get a glue gap if you do a 2x4 glue up to make a cutting board. You don't get a glue gap there. You got wood on wood.
Well, and watching that video that fudge, cutting it close. Ryan, he did that V carve. The tapered ball nose.
He likes tapered ball nose, yes.
When he did a test fit, he put all his glue in and then put the material down, and he's looking. Then he pulled it back out to look and see if he had glue on everything. And he said, this ain't got no glue in it here. So he put more glue back in here and there, and then put it back in again. So, and that was, just setting it in there before he started clamping anything. So I don't know if he's even and I don't know if you're supposed to leave a glue gap on a ball nose taper or not. But everybody I've watched do V carve, they always leave a glue gap somewhere for that glue to get in there and go. And like the old saying, if it works for you, then it's right for you. Steve is working based on pocket calculations, not male female inlay, so that's why inside and outside line matter. Does that make sense to you?
Not really, because I think they still matter.
I cannot learn by others doing it for me. I need to see it, do it for myself. I think I'm going to
that's what I was going to say a while ago, too. It really needs to take the files on machine when he gets some hands-on machine time.
Yeah, yeah. And here's the $1 million question. Uh, I have spent hours. When I say I'll spend 8 to 10 hours a day in here working on the code for this calculator, and
Mhm.
I test fit every single possible combination of. And there's 6 calculators because there's the 3 versions: VBit, straight in mill, and taper ball nose, and then a male and female for each one. So there's 6 calculators actually in that software. And every time I made a change or implemented this or that, I had to go back and test every possible
Oh yeah.
outcome. And now, obviously, I didn't do real world testing for all that, because that would, if it's taking me 8 or 10 hours working on the code, add the setup time and getting everything ready and Z's, and then that would take days and weeks. But I did CAD real world, actually drew them out, test fitted everything, and made sure that all the calculations fit in the drawings.
You see that calculator I made?
Hang on, what you talking about?
I made a calculator to allow you to set a monthly income goal for yourself. It will allow you to add your products, how many you expect to sell per month, how much you expect to sell them for. It also lets you add events and shows that you go to and calculate how many they're going to, how much they're going to cost, how many people you're expecting to see, and tells you how many people you need to cover the cost for that show. And it'll give you a rundown of all your products, and it'll run that math against your monthly goal that you set for yourself. And yeah, every time I added a new feature, you had to retest the whole thing.
Yes, sir.
That's
Yeah.
actually on my website, but I ain't got a link to it yet.
Well, my my I don't mind. Like I said, Chris has seen some of my code and seen some of the calculator. He hasn't seen this full working version yet. And I don't mind your eyeballs getting on it and testing it, but I am scared to death of this thing getting out into the real world, and then it really truly becoming a real game changer for the novice CNCer, and it have be something that actually has some pretty decent value to it, and then it's just pirated and gone, and everybody's got it.
You got to
Uh,
put your name on it everywhere, in the
I've got
code,
it.
everywhere.
It's in the code. It's there, but and I'm going to do the how do you say it? Obfuscation,
Yeah,
uh,
obfuscation.
and try and hide a lot. But you can't stop. I could do a whole lot of that stuff and
Did
put
you
it.
build the entire calculator in one file?
Yeah.
Need to separate that out. It's a web app, right?
No,
Okay, never mind.
no, it's not a web app. You
Mine's a
don't
web app.
you don't even have to be online. And in fact, it's I've done it in HTML and it opens in a browser, but you don't have to be online.
Well, that's the same thing. Yeah.
Okay.
And in that HTML, if you have any CSS embedded, make that a different file. Don't embed that into the same HTML file. And make as many files. If you have a JavaScript, make that a completely separate file. Make your CSS a completely different file. Makes it a little bit more difficult to copy, but I mean, you know, if it's
Now,
out there, somebody can be able to recreate it.
and I started looking at and researching. Well, how can I protect myself? I've the obfuscation and all the other different things, and like now this, what you're talking about. But then I was like, well, can I patent this? And no, because it's math. You can't
Yep.
patent math. Uh, and it's I didn't reinvent anything here. I've just approached it from a different point of view and it's just a totally different approach to stuff, and it's working. And I think it really does work for the simplest of minds. And I've got my hand up. It works for the simple-minded folks. I don't have to fully understand the trigonometry and the Y's and the bit shapes and all that. All I got to do is I know what bit I used and I know how deep I carved it. Put it in there and boom, just do that. I'm like, okay, I'll do that now. And it works. But it's based on tons and tons of testing. And the biggest trick to getting all of it the calculations right with the calculator was having to remember that when you're doing the mail, that everything's inverted, and it a few times that got left out and it screwed up everything.
Oh,
But
yeah.
Chris says, or let's see, Andrew, as you always say, Steve, there's always another way. And welcome to my world of breaking software. If an a-hole wants to be a bigger a-hole, they're going to be that a-hole. Hope that doesn't happen to you. Well, it already has. Yeah, all you can do is keep honest people honest. That's the whole reason for locks on the doors. Locks on your doors on your house ain't keeping the crooks out, it's keeping honest people out.
Just shows people how bad they want in.
Yep. But I was wondering about either making it an app that you could download from the App Store, and people could go online and just buy it and download it, and it's on their phone. And now, no matter what software they're using, if they don't want to start using the, because if instead of in MillMage, you have a pocket and you have the inlays, male, female, all that. Well, if you just used a pocket operation for everything, and then used this information from the calculator, then you should be able to do the perfect inlay just doing pockets. Right? Because that takes the whole thing about the inside, outside, and all that out, because the pocket's just cutting the line, right?
Right.
And
it should be that way.
And if my math is based on cutting the line, then if you just do it as a pocket, then you should be okay.
MillMage.
Yeah.
When you're making a pocket.
Yep.
For the mail section with a V bit, and if you're gonna make anything of any size anyway, that's gonna take an extremely long time. Do they have a way to add a clearance bit, like an 1/8 inch end mill, to take a whole lot more material out before it gets to the V carve?
I do a separate operation. If I understand what you're asking, I do a pocket.
You just have to make it another toolpath.
Yep, I do a separate toolpath with a pocket and my clearing bit, and clear all that out, and then do or one of the other. But there has two different operations. Yeah, yeah. So you have, and I do appreciate your feedback. I appreciate you jumping in here, and you have reservations about it working and how well it's going to work, and
no, not reservations about how well it's going to work. I mean, I just think it should work without doing any offsets.
Well, the offset,
you making those same operations to the top and the bottom would be the same as not doing anything, just using it straight without making any offsets.
Not if you do glue pockets.
Well, even if you have glue pockets, because at that point, all you're doing is setting the bottom depth, just changing that bottom depth just a little bit. Unless you want glue pockets on the side, but I don't know why you would.
No, I'm whenever I calculate my glue, my depth never changes. I'm working for the other side.
Mm-hmm.
So if I change the height of my mill inlay to account for my glue depth, I don't add any or subtract any from my female pocket for glue depth. I change it in the male pocket.
Right. Yeah, you wouldn't want to change that in both. That's correct.
Huh?
You wouldn't want to change that in both.
But
or you'd have twice the pocket.
Yeah, yeah. I'm gonna Chris, as soon as I get have you Jack, have you done any ball nose, taper ball nose?
Oh yeah, I have two. I have an extremely fine tip taper ball nose that I almost never use unless I'm going to do something really small. But I've got a fine taper ball nose, and that's what I do most of my 3D carving with.
Is that what you did? What was it when you shared the other day? Was it a lineman, a 3D?
Yes.
Yeah, that was
I do
gorgeous.
those with tapered ball nose.
Okay. See, that's what I reached out to Ryan to see if he would be interested in helping me test that getting the math right on that taper ball nose. So I'll be interested to get this in your hands, Chris. Chris, have you done any taper ball nose? And Chris says you might need glue on side when inlaying acrylic into wood. A glue gap on the side when you're doing acrylic into wood. Yeah, and
Never
and
done
see that's
acrylic.
that's what I'm with the 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 difference between the basic and the advanced. If you didn't want to mess with any of that stuff, then fine. This is all. There's no side gap, and there's no top clearances. There's no. This is just going to give you a perfect fit. Here you can add for standoff if you want to, but in the advanced, you can start changing and modifying all kinds of different things. The side clearances, and then I've got it set up to where it works in millimeters, inches, and it'll take fractions because I've noticed that. Garrett's, I think all of his stuff's in inches. And I noticed, I think on cutting it close, his was in fractions. Only before Mill Mage days, let Vetric handle it. All right. So you've always let Vetric handle it. You haven't done any. All right. Well, I'm going to, where are we at here? We got about another 10 or 15 minutes and I'm going to jump off here. Get dad fed, get some grub in my belly and get ready for tonight. Then just a teaser. I put in there, I got Charlie Brown's Christmas tree that I'm going to show how to do this, how to cut it up and make it a little nice little stand. Simple, easy peasy. But then, making interlocking trees, and this one's the one I'm working on now. And this is a pain in the butt, getting all the little Christmas ornaments in there. But how to create those from just one simple piece of clip art. That's going to be in tonight. So we're going to be having a Christmas tree farm. Let's see here. Sammy says, should it work with Carve? V-Carve? Yeah, should it work? I'm not familiar. I looked at V-Carve, but that was 3 years ago. I don't remember. And the V-Carve is different now than it would have been 3 years ago. So I don't know how it works. Are you familiar? You use V-Carve? Is that what you said?
I use V-Carve Pro, yes.
Yeah. So, and this, Sammy, or Sam, this is like to Jack. Jack is he says, he's not a pro. If you've seen his work, he's a pro. He puts out professional quality work. And Jack, do you sell your stuff?
I do. I have it on Etsy.
All right. So you sell your stuff. You know the difference between a pro and an amateur?
He makes money. A pro makes money at it.
Pro makes money at it. So guess what, sir? You are a professional CNCer. And so he uses the V-Carve and he gets really, really good results with it. He fully understands it and doesn't need a calculator like this. Can you still use V-Carve and this calculator and probably not with their, just like within Millmage, they've got certain things that they're trying to build in where it's cutting inside the line versus outside the line and where it's supposed to be compensated. Like Chris and Jack have both said, and I hear what you say. You're cut. It's supposed to be. If I've got a 50 millimeter circle, then that at the surface that's supposed to be 50 millimeters, right?
Right.
And regardless of the depth of the pocket,
right?
Okay. That's the first time I've heard that, and I understand it. But in order to do that, the deeper you
see go, a problem right now.
Huh?
I do see a problem right now. It just dawned on me.
What?
Trying to calculate from the bottom of that pocket is going to prevent you from getting good sharp corners in your carve. Like if you have text or if you've got a very sharp point where the top, see those are rounded. See how all those are
Oh, yeah,
rounded?
those are rounded. Yeah,
Yeah.
yeah, yeah. And that's the other thing too, is I've doing and doing the test on this was like the third or fourth time of testing this. There's so much, boys and girls that are new to this CNC world, that you've got to learn. You did all kinds, if you're coming from the laser world, you did all kinds of testing and material test and carve and cut test. The slower you go, the darker it gets. So, if you want to, well, you get feeds and speed ratings with your bits, but that doesn't mean that's what it has to go at all times, period. And sometimes you got to slow it down. Sometimes you have to reduce your step over, how much you feed into it, depending on how tight and fine your pieces are. Because I was doing them with Jack's talking about how rounded the text is. I rounded those over because they did all come to a point, and it was breaking them off, because I was feeding it too fast, too much. It was too much pressure, and I wasn't going deep enough. All kinds of variables that you have to think about. And I said, I got tired of that, so I just took points off of them.
I wish I had my taper ball nose. I could show you how sharp the tip is on this taper ball nose. And when you see that small tip, and then you see my settings, I'm only using 8% of the tip to do my 3D carves. Yeah, they take a little while.
I was saying that takes a long time. I bet. Chris says, I guess, Chris, you're saying that Jack's a black belt CNCer. Is that what you're saying? Or are you?
I think he's talking about him.
Is V-carve the light burn equivalent for small CNCs? I think, where do you put V-carve and Vectric and
V-carve desktop? Well, really the only difference between desktop and V-carve Pro is the size that it allows you to work with. If you've got V-carve desktop, that's everything 24 inches by 24 inches or smaller. If you want to go bigger than 24 inches, you got to go to Pro, and it's like $600, but it's some pretty nice software.
And see, and the machine I've got is 4x4, and so that's when I was looking at, because I was wanting to make 36-inch signs and all that kind of stuff, and I said, I got to make a whole lot of signs and sell a whole lot of signs to pay for $600 a month. And when you're learning, it just
one-time fee.
Huh? I mean, yeah,
yeah.
Still, what's that come out to? It's a little less than 60 a month for the first year. It don't take a long time to pay that. And it don't include updates and stuff, though, does it? It's just
within that version, yes. If you bought into V-carve 12, you'll get all the V-carve updates up until V-carve 13. You can still use 12 from now on, and it's always yours. And it's just like with Lightburn. I have not upgraded to Lightburn 2 yet. I'm still seeing people. I'm still using 1.7.08.
Yeah, well, I'm keeping the most up to date version in Lightburn, so I can see the problems and complaints and what people are hollering about, and I'm still got bugs, but I've got a new appreciation for the coders now. That can be huge nightmares, especially when you're just, I'm gonna make this better, and all of a sudden you blow the thing up. Oh man. Yeah. Chris says use Jack's calculator to work it out. Haven't bought my first CNC yet, maybe early next year. I tell you, Mike, and a lot of people I've seen a lot of people complaining about the Cubico in the Facebook group and everything else. And I think the issue with the Cubico, 90% of it is it's not an advanced machine. It was never supposed to be an advanced machine. It's a simple little machine. And the people who are buying it are people like myself who don't know what they're doing. And if you combine it, you don't know what you're doing, and it's not doing what it's supposed to do, people get flustered and they're breaking bits and but I've got my firmware updates, got all that straightened out, and got everything, and now it's working exactly like it's supposed to. But there are some other issues out there that folks are getting machines replaced. But it's what, $450 or something like that. I mean, it's not a $2,000 or $3,000 investment, and that's why I still think it's worth rolling the dice on something like this to learn how to use it. Because you start here. This is my test material. This little piece of material right here. You go in there. You could do this with the big 40, the 4 foot by 4 foot machine, but how do you? It's not designed to strap or to mount little pieces like this. It's made to mount big pieces of material. You can tape it down. You can do it. It's just more work, more cumbersome. It's a big machine. I like this idea of learning with this little bitty thing. And then once I get it all tackled, then I can go to the big boy. Yeah. Chris says Cubico is like a tasting platter for CNC. So yeah, you want to get your feet wet, maybe you try that, and then you step up.
You definitely don't want to go buy a $2,000-$3,000 machine and figure out you don't like CNC.
I've got one in mothballs back there because I couldn't afford the software to do what I wanted to do. And did you ever use Easel?
I've tried it a couple times. That was trash from the get-go.
Thank you. I don't know what I'm doing, and I recognized it was garbage.
Yeah,
and I was like, I'm not wasting my time with this. And
my first CNC, I actually 3D printed. I 3D printed the MPCNC. The only problem with it is it runs Marlin, and Marlin is great for 3D printers, but it is not great for a CNC machine. So I'm fixing to actually take it back out and put a Gerbil board in it so I can run it with G-Sender.
And that's another thing I was wondering about is, and I've never used G-Sender and I don't understand it. I know what it is. It's what's sending your G code to the machine. But if you were to use some type of basic, well, you've got to have the ability. The ability to create the G code for the Z axis. I was just trying to think what the least, because I honestly think that you could take a piece of crap software like Easel that has the ability to do those, to write that code and use my calculator, and you could trick Easel into doing more complicated stuff, I think.
Chris said he couldn't use Easel either.
Yeah. Mike says it's more of a space thing. Got too many lasers, and yeah. Well, let's see. Just for giggles, if you decide media, is this what I want? No, I don't want that. Banners. There we go. Did I do one? I don't think I made a banner for it. hobowithwood.com/cubico. hobowithwood.com/cubico. No, I didn't make a banner. If you use hobowithwood.com/cubico, that'll give me enough money to buy dinner one night. And you can get your feet wet and see if it's something you want to do as far as CNC goes without spending. Because otherwise, even and I haven't looked at the prices on those other ones because this one's postcard size. They've got some out there to do what, like 12 by 12?
Yeah, that's all kind of different sizes.
Yeah, but those are probably going to double in cost, and you're starting to get. You're still not going to be $2,000, but I had over $2,000 tied up in a machine that's been sitting in mothballs for 3 years. You don't want to do
That's
that.
a shame.
Yeah. All right. Well, boys and girls, I appreciate Jack popping in here, and I'm going to put that calculator in his hands and see if he can break it. I'll
You're breaking stuff.
And if, like I said, if you're interested, tell a little lady we can go over to Texaco. Thank everybody. I appreciate y'all for hanging out for a little bit today. And if you are interested in creating these Christmas trees from just base. And I'm even going to show you how to get the artwork for free. If you don't have the artwork, we're going to go to a free website. You get the free, and this is some of the simplest things you can do. And we're going to start with just a flat, one piece that you cut out of 3mm plywood. And then I'll show you how easy it is to make those interlocking and twist them and make them, instead of just one dimension, you got all 3 dimensions going on. Melissa's saying thanks. Bob, thanks. See you tonight. Big Mike, yeah, thank you, brother. Thank you for coming. Jack, let's get out of here and go feed our face.
All right, I appreciate y'all putting up with me for a little bit.
Well, I appreciate you coming and hanging out with us. All right, everybody. We'll see you this evening, 9 o'clock Eastern time, which will be just a little over 4 hours, 4.5 hours. Yeah, 4.5 hours. All right. See you in a bit. End stream.